Okay, in this video I'm going to show you how to make an AND logic gate. Before we continue, I'll show you the circuit diagram, or the truth table, sorry. Inputs A and inputs B and output X. You'll notice that only when inputs A and B are high do you get a high. For every other combination you get a low. The circuit diagram here for an AND gate is this, where you have your inputs A and B and your output X. Notice the dot, or the circle, is the Boolean symbol for an AND. Down here I have the circuit diagram. I'm using a bipolar junction transistor, or BJT. This is the circuit diagram for a BJT, where we have a base, a collector and emitter. See other videos I'm using, or I've put up, in order to find out about the BJT. The BJT I'm using is a BC547, which is also called a 2N2222 transistor. The resistors I'm using are 600 ohms. So on my circuit diagram I have a 9 volt high line here and a 0 volt or ground low line here. Notice that my high line is different to most circuits where they use a 5 volt input. I'm just using a 9 volt because it's easier to get. So you'll see my inputs A and B here connected to the bases of my transistors, and I actually haven't physically connected them to the high line. I'll leave those wires separate so I can make them high or low as I want. Right, so let's go and build it. So here's my breadboard. I've left in some wires already just to make life easier for me when I'm building the circuit. Points note are here on the bottom. This is my low or 0 volt line, and up here, along here, this is my 9 volt or high line. So the first thing I'm going to do is I'm going to put in this transistor here. So I'm going to go from high and into the collector of my transistor. Here is a bipolar junction transistor. Points to note are, on the right hand side as you look at it, you have a circular side, and the left you have a flat side. Keeping the flat side to you, you will have the collector on the left, the base in the center, and the emitter on the right. And I will put my transistors in so that the flat side is facing to your left. So I'm just going to put that into my circuit. Like that. Now this yellow line here, that corresponds to this wire coming down here and into the collector. This brown wire here is the base on my transistor. Okay, so you have my high line coming into the yellow and then going into the collector on my transistor. This brown wire here is the base, and what I'll do is I'll put a resistor along here and leave the input not connected. So here is my resistor. Okay, a 600 ohm resistor. I'll put that in there. And this green wire here is going to be my A input. I just connect that in series with my resistor, but leave it disconnected. Next I have to do my second transistor, input B. This here. So what I'll do is I'll connect the emitter on transistor 1 to the collector of transistor 2, and I'll set up transistor 2 in a similar way to transistor 1. Here's the transistor again. That brown wire here is the base for that transistor, and I'll do the exact same thing as I did with my previous transistor. So what I've put in so far is all up along here, and what I'll do is I'll put the emitter through a resistor and down to low, down to ground. So here's another resistor, and I'm going to have that coming out of the emitter of my second transistor. And this line here goes down to ground, so I'll just show you that, give you a close-up. Okay, so as you can see here, that's the That's the collector of transistor 2 and it's connected to the emitter of transistor 1. There's the baseline coming into the resistor and from the resistor into the output number B. Okay, that's the exact same for transistor 1. Then I have my resistor here on the emitter of transistor 2 into this wire here which goes down to ground. Just down to here. Alright. Now it's time to put in the output. The output will be between the emitter of transistor 2 and the resistor. And I'm going to put it through a 3mm LED and put that to ground. This red wire here is going from the emitter of transistor 2 and this orange wire is going down to ground. So I'm just going to put in my 3mm LED. Here it is here. You will see, if I bring it close, there is a longer wire, a longer leg and a shorter leg. The longer leg is always positive, as I said that's red. So I'm just going to put that in like that. And I think it's time for you to see that up close. If that gets in focus. So you can see that there's the emitter of the transistor 2 that's in series with the resistor going to ground and also in series with the output which is going into my LED and which is going to ground. So it's time to test the truth table. So inputs A and B are currently low. Input A is high, input B is low and I get a low. Input B is high, input A is low. Now this is coming on here and I'll speak about that in a moment, but that's actually a low at the moment. And if I put two inputs high, I get a high. Okay, I'll do that again. A and B high and I get a high. A and B high, I get a high. Now this setup as an AND gate is actually quite poor in that with, if I put B high on its own, I get some form of an output current going through my LED. That is a low current. So you'll see if you look at more complicated AND gates that they look better, or they look more complicated of course, but they perform better, and this actually wouldn't light. But as you can see, there's a marked difference between when both are on and both aren't. And that's how you make an AND logic gate.